Okay, so p hat is going to be 408 divided by 865. And so next what I have to do is find my standard of error. So it would be so it'd be, evidently I can't do it this high. Okay, so it's going to be 408 divided by 865 times 1 minus that, so that'd be 865 minus 408. So I get 457 divided by 865. Oh, divided by 865. Okay, so there's my expression. So now I'm going to go to my calculator, and I'm going to go put it in. So my number of hits is 408. My n is 865, and it's at a 95% confidence. So that's 4384 2.5049. Okay, so now I'm going to interpret it. So I'm going to put it down here at 40.
I'll be here.
Okay, so I'm going to say we are 95% confident that the true proportion of 865 voters in Delaware that approve an issue before the legislature, whatever that's pronounced, legislature, is between 43.84 to 50.49%. Yes, that is a handful. Okay, I'm going to go change colors. Okay, so let's do this. They say that the germination rate, how you pronounce that, is 92%, and we have 160 packets. Okay, so my expression is going to be 0.92 plus or minus 2 times the square root of 0.92 times 0.08 divided by 1160. Okay, so let me go do the math and I'll come back. All right, so I notice here, remember, if you're going to use the graphing calculator, you need to know the number of hits. And so to find the number of hits, it's going to be 0.92 times 1160, and I get 1067.2. So I'm going to make my hits be 1067. So it's going to be 1067 out of 1160 in a 95 confidence interval. So it's going to be 0.9042 to 0.93455. All right, so let me erase what we had here so I can write my delightful confidence interval. Okay, and so I'm going to say we are 95% confident that the true proportion of 1160 seeds that will germinate is between 90.42% to 93.55%. Okay, great. Okay, so here what we're doing, we're gonna do a sampling distribution. First of all, I need to find my standard deviation. So my standard deviation is 0.7 times 0.3 divided by 20, and I take the square root of that. 0.7 times 0.3 divided by 20, and I take the square root, and I get 0.102. Okay? So draw my horizontal line, I draw my bell curve, I label this, and my SD is equal to 0.102, and I need to go 1, 2, 3 out, and then 1, 2, 3 out. Okay, so now I'm going to add, so 0.7 plus 0.102, and I get 0.802, and then I'm going to add, and I get 0.904, add point, and I get 1.1.006. I'm going to go the other way, 0.7 minus 0.102, and I get 0.598, 0.598. Oops, subtract, and I get 0.496, 0.496, and subtract, and I get 0.394. Okay, now remember I'm going to do 68%, 95%, 99.7%, and this is the proportion of people who speed. So this is the proportion of speeders. Okay, I'm running out of room here. Okay, and so they want to know what is the proportion that more than 75. So I'm going to have, so I got to do my proportion statement. So the probability that x is greater than 0.75 is equal to, so let's go do my, going to quickly sketch my curve. So this is p is equal to 0.7. My standard deviation is 0.102. Here's 0.75. And so what do I get? Z is equal to 0.75 minus 0.7 divided by 0.102. 0.75 minus 0.7 divided by 0.102. And I get 0.49. Okay, so I am going to use my calculator. And my lower bound is 0.75. My upper bound is infinity with a 0.7, 0.102. And I get 31.2. So this is 0.3120. Okay, should the police be surprised if 16 of the 20 cars are speeding? So 16 divided by 20 is equal to 0.8. So Z is equal to 0.8 minus 0.7 divided by 0.102. So 0.8 minus 0.7 divided by 0.102. And it gives me 0.98. And so the answer is no. And it's because 0.98 is less than 2 standard deviations from the mean. Okay? Hopefully that makes sense.